We are going to pick up some straggling questions from lesson 2. You remember this question? Tell your neighbor and tell them why.
I was curious.
Correct answer is B. Okay. Moving at a constant velocity, some of the forces are equal to 0. Okay. Here is a follow-up question. Tell your neighbor. Correct answer is B. Okay. It doesn't matter how fast you're going. If you're moving at a constant velocity, inertia is doing what it wants to do. It's happy. It's like, yes. Okay. Think about a scenario in your life. If you're like plugged in AirPods, you're in the back of a car, you're riding, you're not looking out the window, you're just messing on your phone. Can you tell how fast you're going? If you're in a nice car, good suspension. Doesn't matter. You're going 30 miles an hour, 70 miles an hour. Doesn't matter. Your inertia is doing what it wants to do, is moving at whatever rate that is. So sometimes I'll throw in, hey, you're moving at a constant 0.75 meters a second and a problem, and you're like, oh, I got to do something with that number. If it's a constant velocity, no, you don't. Okay, so just heads up on that one. Okay. Sorry. Yeah, we'll call that good. Talk to your neighbor. Tell them why. So it's this process here. Okay. Before I let go, Correct answer is? Correct answer is C. What should I look at to determine if the sum of the forces are equal to 0 or not? More general than constant velocity and acceleration, yes. You should look at the motion. Okay, how would you describe the motion in this scenario? Speeding up, slowing down, constant velocity, speeding up, started at rest and now moving. Okay, so what is the direction of acceleration? Up or down? Is everybody okay with up? Okay. You are speeding up upwards. So if you have an upward acceleration, you must have an upward net force. Total force going up. Good with that? Okay. Next question. After, leave your hand. Tell your neighbor. Correct answer is A. Just force of gravity. Okay. None of this like. Okay. And inertia is not a force. Okay. All right. What about the catching part? To visualize this, consider, have you ever played like egg toss or water balloon toss, trying to catch something without breaking it? Think of it like that, like visualize that. Like this is easier to like versus like that. It's the same thing. It's just this is more gradual. You can consider it better. Tell your neighbor what you think. Tell them why. Oh, good question. Nope. This one has more, like this is the force of gravity. This is like additional forces going down. Correct answer is how would you describe the motion? Speeding up, slowing down, or staying constant velocity? Slowing down. What is the direction of acceleration? the direction of velocity. Direction of velocity is down. Slowing down while moving downward, the direction of acceleration is the opposite direction of velocity, up. You follow that? So if the direction of acceleration is upward, the direction of the net force that caused that also has to be upward. Correct answer is D. Dangerous dinosaurs. Okay? If this is the case, how would this be moving? It would keep on going down. If this is the case, how would it be moving? Still be speeding up. Not as much as in free fall. It wouldn't be 9.8. It'd be something else. And this is like inertia being a thing, being a force. How we doing? Okay. So the net force is always in the same direction as acceleration, not the velocity. So if you said B, that was kind of the misconception that just got confronted. Like, oh, it's moving down. The net force must be that way. No, the net force has to be in the same direction as acceleration, not the velocity. Okay? It's a great day if you learn something. Thumbs up when you have a guess. Have a conversation and tell them why. Correct answer is that a unanimous C or a, that's what we're thinking C? Like, that's what some people see. Okay, good job. Correct answer is C. Quick demo for you. What I have here is a fan cart. 2 fans. Okay. Okay, speeding up. Okay. Do that. Constant velocity. Okay. I'll do it back here. To be 100% honest with you, I had to rig this because this flooring is kind of squishy and there's friction. And so I had to make this one weaker than that one so that the fan plus the friction would end up being equal to that. Does that make sense? Okay. So we're speeding up. Now we're going at constant velocity. Good there? Okay. What would have to be true for B to be correct? Ethan. Yep. There'd have to be, like, if this was 11 or like another force of 1 or something. Okay. In order for A to be true, there'd be a huge but momentary force. Like wham! A huge force. And then bring it to 10 to keep it at rest. You're slowing it down real fast, like huge acceleration. That makes sense? Okay. Good job. Skipping back to where we left off yesterday in lesson 4, if you're following along. Okay, set this one up. Yeah, you might have flipped your right and left around. That's fine. How did I know that some of the forces in the x direction are not equal to 0? What tipped me off? So when you're trying to figure this out, what am I trying to coach you to look at? The free body diagram or the motions? The motion. What about the motion did you know? Started from rest and now it's not. How do we do? Grade yourself. On the setup. Okay. Now, once we have the setup, what ultimately are we looking for in this problem? Displacement or distance. Where do we find displacement or distance in our setup? Mr. Smiley, you lied to me. I don't see any of that distance displacement in there. Fair enough. But what do we know about the motion? What in our setup tells us anything about the motion? Oh, come on. Anything up here tells us anything about how it moves? Acceleration. I have acceleration. I'll have a value for that. What else do I know about? You know it's mass. We've incorporated that. What about anything else that we have numbers for that? Okay, that's true. We know we'll figure that out here in a second. We know the time it travels. What else do we know? Or Justin. Okay, we do know that. We have that captured here. Brandon. Whatever could we use to figure out displacement? Some people see it. I see it in your eyes. Yes, sir. Kinematic equations. Woo. Yep, they're here to stay. Oh, yeah. Okay. So, if we find acceleration, does that make sense? Still a thing. So, here we have 7 newtons minus 2 newtons equals mass. Can I plug in 0.75 for here? Can I plug in 0.75 in for here? What's the unit for mass? Kilograms. Can I plug in this into here? When I ask questions, I will always ask them in a way that like you're like, I don't know. I'm not going to try to lead you one way or the other. Okay? Why? Because your brain's going to do that on a test. I don't know. Are you sure? I don't know. Okay? You got to know it. It's in kilograms. That's mass. 0.75. Are we good? Like we're locked in on that one? Acceleration. So 5 divided by 0.75 gives you 6.67 meters per second squared. So that can be used there. That's 0. Delta x, 1/2 times 6.67 times 3 seconds squared. Gives you 30 meters. Lab and all. Got it. Good there? All right. Tell your neighbor. Correct answer is B. And it has the same ratio of force to mass. Good at that. I know this is an absurd scenario, but just go with it. Tell your neighbor. Does everybody go C? All right. Here's why I bring up this question. First off, mathematically, are we ever going to be able to make mass big enough that makes A 0? Okay. So, regardless of how massive it is, force will always win. There will always be some acceleration. There might not be much, but there will be some. Inertia won't be happy. You good with that? The second thing I want to bring up is this idea that, okay, so you have this huge force of gravity. And you have this equally huge normal force. And you have this itty bitty, like that's you trying to push on your house in comparison. But mass does not cancel out force. Neither does the force of gravity cancel out something acting horizontal. Okay, they're independent of each other. The only thing that's going to make this at rest is if there's some other force in the horizontal direction that cancels that out. Force only cancels out forces. Okay, hear that? Already talked about that. Okay, now check this question out before you answer anything. See the difference between this question and this question? Tell your neighbor the answer to this original question. Tell them why. Correct answer is? Correct answer is B. What's another name for force of gravity? Weight. Do they weigh the same? No. The correct answer for this one is A. They both experience free fall, 9.8 meters per second squared downward. You see the difference between this question And this question, the force of gravity is weight. The acceleration of gravity, that's 9.8 meters per second squared downward. Everybody good with that? Okay. The recommendation would be set it up. You can round G to 10. Tell your neighbor. Okay, assuming that both tensions are equal, is this equal to the force of gravity? Is this equal to the force of gravity? Gotta watch that. If this was that, would this be equal to the force of gravity? It's in kilograms, it's mass. So we're gonna round that to 10. Correct answer is C, 250 newtons. Good at that. Questions there. Things learned. Things learned again. Some people think this is a snake. Tongue sticking out. Yeah. All right. Last one. What do you think my recommendation is going to be? Set it up. Tell your neighbor. Okay, popular wrong answer is E. It's like, hey, check it out. Mass, force, force divided by mass, boom, acceleration. You forgot about gravity. That's still a thing. We're on the surface of the earth, okay? So doing your setup, regardless of how easy you think it is never a bad thing to do. Sometimes it can prove to be a very beneficial thing to do. Okay, so we're multiplying this by 10 to give us force of gravity. Oops. Good with that. Correct answer is B. Good with that? All right. Worksheets due on Friday, not Thursday. Okay. We'll do a lab tomorrow.